Welcome to the firewall lesson. Click Next to get started. After completing this lesson, you'll be able to achieve these objectives. Define firewalls and their evolution. Describe how firewalls work. Explain the latest firewall status. As networks began to grow, interconnect with one another, and eventually connect to the internet, it became important to control the flow of network traffic. Firewalls became a means of control that had to evolve and change alongside networks. They're classified into generations, defined as first-generation packet filter firewall, also known as stateless firewall, second-generation stateful firewall, third-generation firewall, and next-generation firewall, NGFW. The first-generation firewall is a packet filter firewall, also known as a stateless firewall. It examines the routing and transport layer protocols information, such as source and destination network addresses, protocols, and port numbers. Firewall policies use these attributes to define which packets are allowed through. The rules are ordered in a list, and the potential match is performed in order from top to bottom. The last firewall policy can be implicit, denying the packet by default, or explicit, performing the corresponding configured action, or either allowing or denying the packet. A stateless firewall allows a packet to pass if the network addresses, protocol, and port number match those of its firewall policy. If it does not, the packet is either silently dropped or blocked. Click the buttons for more information. A drawback of stateless firewall is that it requires additional configuration to offer suitable level of protection. For example, it requires an additional firewall policy for return traffic in a session. It also fails to appropriately manage protocols. Stateless firewalls open random ports and use multiple connections like FTP with its control and data connections. Stateless firewalls use a one-size-fits-all approach to decide whether to allow traffic to pass. Because of this open approach, bad actors can potentially bypass firewall rules and inject rogue packets through acceptable protocols and ports, or exploit bugs in a computer networking software. The second generation of firewall, known as a stateful firewall, offsets the limitations of the stateless firewall by developing additional criteria for blocking or allowing traffic. A stateful firewall is designed to observe the network connections over time by tracking the 5-tuple check and the connection state in its session table. It watches as new network connections are made and continuously examines the traffic going back and forth between the endpoints. If a connection behaves improperly, or if the return traffic does not match the corresponding incoming traffic, the firewall blocks that connection. Any packet that does not belong to a known conversation or does not match an allowed firewall policy is dropped. Click the button for more information. While stateful firewalls are an improvement, they still cannot block rogue packets if they're using an acceptable protocol, such as HTTP. The explosion of the World Wide Web promoted HTTP as one of the most frequently used network protocols. The problem is that HTTP is used in many ways, such as in static text content, e-commerce, file hosting, and many other types of web applications. Because they all use the same port number, the firewall is not able to distinguish between them. Network administrators need to distinguish between approved and malicious applications to determine which ones to pass or block. Firewalls must look deeper into the data payloads to determine how protocols such as HTTP are used. The third generation of firewall looks deeper into the data payloads. While still stateful, these firewalls understand the application layer protocols and control different uses of the same basic protocol. This is known as application layer filtering. Firewalls that implement application layer filtering can understand protocols such as HTTP, FTP, and DNS. HTTP can distinguish between browser traffic, a blog, a file sharing site, e-commerce, social media, voice over IP, and email. UTM firewalls also combine additional protections like antivirus, anti-spam, an intrusion prevention system, IPS, and a virtual private network, VPN. Click the underlined terms for more information. Today, the prevalence of the internet has changed the way of working, playing, entertaining, and doing commerce. Businesses have evolved to take advantage of cheaper multi-cloud services, and the convenience of mobile and IoT devices has dramatically expanded network edges, thereby increasing the attack surface. Just as the internet has evolved, so have threat actors. They continue to change in terms of attack methods and level of sophistication. Attacks can now come from trusted users, devices, and applications that spread malware, both unknowingly and with malicious intent. A firewall must prevent evolving cyber attacks at every edge of the network while delivering security, reliability, and network performance. Next-generation firewalls like FortiGate provide these advanced security capabilities. A next-generation firewall operates like airport security, with both having multiple security checkpoints. Just as a security agent looks at your boarding pass as a first line of defense, a next-generation firewall looks at packets and makes rule-based decisions whether to allow or drop the traffic. Next, your travel bags are checked by security to see if you're carrying any banned or malicious items. This is similar to the way a next-generation firewall performs Deep Packet Inspection, DPI. Click the underlined term for more information. If suspicious items are found in your travel bag, an airport security agent sets the bag aside for enhanced screening. In a similar vein, the next-generation firewall sends malicious content to a sandbox for further analysis. Click the underlined term for more information. As networks continue to evolve and introduce new challenges, next-generation firewalls also continue to evolve. For example, next-generation firewalls can control applications, either by classification or by who the user is. Application-level security helps protect web browsing clients from attacks and threats. Next-generation firewalls also adopted various segmentation approaches that segregate users, devices, and applications that are aligned to business needs. By segmenting networks rather than using a flat network, the firewall helps eliminate a single point of entry which used to make it easier for cyber criminals to enter and spread threats across the network. Within these challenges, firewalls are evolving from reactive to proactive devices, using artificial intelligence to enforce security policies. Next-generation firewalls also deliver high-performance inspection and greater network visibility, with little to no degradation, to support and protect modern distributed data centers located within a complex and hybrid IT infrastructure. Hybrid data centers offer businesses greater agility, flexibility, and scale on demand, as well as an expanded attack surface that requires an equally evolved security strategy. High-performance inspection includes applications, compute resources, analytics, encrypted data that moves throughout the infrastructure, and data storage across multiple private and public clouds. You have completed the lesson. You're able to define firewalls and their evolution, describe how firewalls work, explain the latest firewall status,